Which of the probability distributions below is discrete and which is continuous? How many outcomes are there for each? So here we have a histogram. And anytime you have a histogram, that means that the probability distribution is discrete. Here we have a curve, and anytime we have a curve, that means the probability distribution is continuous. Now, how many outcomes are there for each? It's actually really difficult to say in both cases. It might be that every class has just one outcome, in which case there are 5 outcomes. Or it could be here in the histogram that every class has 2 outcomes, in which case there's a total of 10. We just don't know. That information is not available to us. What we can say is that the outcomes here, because it's discrete, can be counted. Whereas the outcomes here cannot be counted. They can only be measured. Outcomes for any continuous probability distribution can only be measured. And an example of each might be such as a binomial, which is certainly discrete. The number of successes can be counted, in which case the distribution is a histogram. An example of a continuous variable might be one in which you're looking at, say, time to watch a cool statistics video. The difference being, binomial, you count the number of successes, whereas the time to watch is not really measured in hours or minutes or seconds, but not even hundredths of a second, but on a continuous interval. So that's why the shape is different. When you count, you go from one class to the next, whereas in probability distributions that are continuous, you smoothly go from one to another. And that's the type of variables that we're going to be looking at in Chapter 6.